Hello and welcome to this bit of a special episode today, because we've kind of wrapped up all derivative rules in the calculus series. So today I want to attempt to solve 25 derivatives in one go. I'm not sure how long this is going to take. Kind of depends on the difficulty of the functions before me. But the goal will be for each function to find the derivative of y with respect to x. So I've kind of laid them out like the first bit you should be able to do with the first few episodes, and then later on we get trigonometric functions, we get logarithmic functions. They're kind of laid out in the way the videos are uploaded. And these greens, these in the green section, they're just all over the place really. They're yeah, they're kind of right. They're the more difficult ones. So, and also a bit more in the logarithmic section. It looks a little bit. I picked these, but I picked them kind of at random. I don't really know. Some are easier than others. But some I don't really know how to tackle yet, like this one. Okay, but we'll just keep going and we'll see where we end up. You can try to follow along, I recommend you to follow along if you've been watching this series. Because practice is very good and I want to showcase that. So here are 25 practice problems. So I'll be attempt. Okay, let's just begin. Alright, we'll start with the first one. The first one is gonna be y equals b, and this one's actually this one should take mere seconds because b is just a number, right? It's gonna be 0, a half, 3, something like that. And the derivative of a number is always 0. So, bam, that's the first derivative. Well, if they're all going to be as easy as this, then we'll be done in no time. But I fear not. Alright, the second one. That's x squared plus x plus 1. Okay, second one. X squared plus x plus 1. Alright, so this is just applying the power rule, right? So the 2 jumps down, we get 2 times x. You can imagine a 1 jumping down in the x to the 0, that's just 1. So we'll just get a 1 here. And then this 1, again, that just vanishes like that. So that's a final answer. The derivative of y is 2x plus 1. Alright, the third function, that's going to be this one. X squared plus 2x plus 1 all cubed. Alright, let's just copy that. X squared plus 2x plus 1 all cubed. And you might choose to say, you can immediately use the chain rule, and that's true, chain rule and the power rule, right? But I do want to be a little bit clever about this, because I recognize that this is it's just a product of, it's actually quadratic. Like we can say that this is x plus 1 squared, like that. And then we can raise it to the power of 3, and then we can just multiply the exponents together, so we'll get x plus 1 to the 6th, which, look at that. And this one's even easier to differentiate. That just becomes 6 times x plus 1 to the 5th, and I can multiply by the derivative of the inside, but that's just 1, so this is the final answer, like that. Alright, so I'll change color really quickly. Alright, so the first 3 were alright, so now to the fourth, that's going to be the reciprocal of the square root of 3x plus 1. Alright, so y, like that, 3x plus 1. And I'll quickly rewrite this as a power of 3x plus 1. That's going to be negative a half. A half for the root and negative because it's a denominator. Alright, so now we can again use the chain rule for this. So we'll get a negative out front, negative a half out front. 3x plus 1, that remains the same. And then I subtract off 1 from the exponent. That becomes negative 3 divided by 2. And I still have to multiply by the derivative of the inside. That's going to be the derivative of 3x plus 1, which is just 3. So when multiply by 3, simplify this a little bit, it becomes like that. 3x plus 1 times the square root of 3x plus 1. Alright, so that's our final derivative. They're getting a little bit more, but it's still very doable. Alright, so now we have y equals 1 divided by 1 plus 1 divided by x. Alright then. Let's copy this. 1 divided by... Alright, so I'm thinking we can do this one of two ways. Either we can say that this is just 1 plus 1 over x to the negative 1 and apply the chain rule, or I can say that this, if I multiply both the top part and the bottom part by x, I get x divided by x plus 1. And I think I'll go with that part and use the quotient rule actually. Yeah, let's go with that. Alright, so I'll use the quotient rule, so that becomes the bottom part squared. And then we have x plus 1, that just becomes times 1, right? Because the derivative of x is just x, that's just 1. And I have to subtract off the derivative of this, that's just 1, which is just like that. So actually the derivative becomes negative 1, that x, those two x's cancel. And like that, x plus 1 squared in the denominator. So that's quite a nice derivative. Alright, so now the sixth. Right, alright, we're now already at the exponents, but it's still doable. E to the x plus x to the e. It's kind of a nice function. Alright, x to the e. Oh, I switched them. I hope you don't mind. Alright, the derivative of this. Well, we can just do this in two parts, right? Because we have two functions added. So let's first concern ourselves with x to the e. Now you might be a little bit confused by this, but don't be, because e is just a number and we can just apply the power rule. So that'll become e out front times x, and then we have to subtract off 1 from the exponent. And e to the x, that's even simpler, that just becomes e to the x. Like that. And that's our final answer. Alright, the seventh function now. That is e to the 2x plus 1. Alright. Y equals e to the 2x plus 1. Alright, this one is also quite easy because it's just using the chain rule. But you do have to recognize that you have to use the chain rule. So first of all, if this e to the x bit just remains the same, and then I have to multiply by 2, which is the derivative of 2x plus 1. So that just leaves me with 2 times e to the power of 2x plus 1, which is the derivative. Alright, so we'll get to function 8 now. It's going quite well, I think. Alright, so here we have 2 to the power of the natural logarithm of x. Okay. Y equals 2 to the power of the natural logarithm of x. Now I could do this with the chain rule and the power rule or the exponent rule, but that's just a little bit too complicated, I think. Because what I can do, so I'll quickly write this in a different color. Red is nice. I can recognize that ln of x is also just the log base 2 of x divided by the log base 2 of e, right? Because the base of ln is technically, it's log e, so I have to divide by the log base 2 of e. Alright, so I'll plug that in, so that becomes 2 to the log base 2 of x, log base 2 of e. And now I can actually say, because these two are technically multiplied together, I can say that this is log base 2 of e, right? All that to the power of, or rather 1 divided by. Actually, no, let me switch that around. That's not silly. A little bit silly, like that. Alright, and then that to the power of log base 2 of e. Because actually what happens here is we have 2 to the power of log base 2. Those two just cancel and we get x to the power of 1 divided by log base 2 of e. And again, this is just x to the power of some number, right? So this just becomes, we can just use the power rule here to find the derivative. That just becomes that out front, and then I subtract off 1. Right, so the lesson here is to think before you start applying rules, right? Because this is quite a simpler function. Now it might be the same work if you did this way as if you were to just immediately start differentiating, but I think this one leads to a bit nicer function, right? Because this one's a little bit messy. Alright, let's do the ninth function now. It's going to be x plus 1 times e to the x. Alright. Let's copy that. X plus 1 times e to the x. This one's just using the product rule, quite simply. Just copy this, x plus 1, derivative of e to the x, that's just e to the x, and then do the derivative of this, that's just 1, times the original e to the x. And I can actually just factor this out like that, and it just becomes x times 2. And that's the final answer. That's pretty easy. That's quite doable. Alright. The next one up here. Oh, this one's quite a one. This is quite a one to copy. That's going to be, well, I'll just copy this in part. This is 3, I believe. X cubed plus 3x plus 1 cubed. That's the first part. X cubed plus 3x plus 1 cubed. And I believe it was times 5x times, let me have a quick look, negative 1. Alright, negative 1. Like that. Alright, that's y. And you might want to start expanding this because you have an exponent here and then use the product rule, but that's just a little bit complicated. I'll just immediately start using the product rule and treat this as an entire function. So first of all I have to copy this, right? That's easy enough. 3x plus 1 and multiply by the derivative of that, that's just 5, so I'll put that 5 out front. And then I have to add by the derivative of this, that's going to be a little bit more complicated. The 3 jumps out front and we just leave the inside the same, that's by the chain rule. And I have to multiply by the derivative of the inside, well 3x, x to the third, that just becomes 3x squared. And then 3x, that just becomes 3, and 1, that goes away. And then I still have to multiply by 5x minus 1. And I'll just leave that, I'm not gonna, oh, excuse me. This should be a cube, and this should be squared, like that. Alright, and I'm not gonna expand this, that's just a little bit, I'm not gonna do that. Alright, so now we'll go to 11. Let's see what's 11. 11 is 1/5 to the power of x divided by 2x squared minus x plus 1. So we have 1/5 x, and then we have 2x squared minus x plus 1. Minus, was it minus x? Yeah, minus x is correct. Alright, I will just use, actually, I'll quickly rewrite this to 5 to the negative x. I think that's just a little bit nicer. It's a little bit nice to work with. Alright, so I think I will just use the quotient rule here. Yes, I will just do that. Quotient rule, well, we'll square the bottom part. Negative 1 plus squared, alright. And then, well, this remains the same first of all. Just copy the denominator. And we have to multiply by the derivative of 5 to the negative x. Well, we have to use the chain rule here, so we have to multiply by negative 1. And just use to the natural log of the base times 5x times negative 1. It's quite a derivative, this one. And I have to do minus just the regular top part, alright, 5 to the negative x. And then do the derivative of the denominator, that's going to be 4x minus 1. Alright, now actually factor out 5 to the negative x, it should be negative. Negative 5 to the negative x times, what's this going to be? ln 5 2x squared minus x plus 1 minus 4x plus 1. Alright, this one's quite messy. Still all over this. Like that. Alright. That's the final derivative. That's a bit that's a big one. Alright. So derivative 12. That's gonna be log base 2 of e to the 2x plus 2e to the x plus 1. Alright. Let's go down again. So derivative 12, oh that's derivative 11, derivative 12, log base 2 of e to the 2x plus 2 e to the x plus 1. Alright, so we have to find y, the derivative of y. So we have to use the chain rule here, right? But first of all, we might want to rewrite this logarithm in terms of ln x. I think that's a little bit nicer. So I'll just first of all copy this up here and then divide by ln 2. Alright, so now we can, now you might want to use the quotient rule here, but watch out because this is just a number, right? So you only have to concern yourself with the top part. This just remains the same. So it's technically just a factor. Alright, so the top part, actually first of all I will factor this top part because I see that this e to the 2x plus 2 e to the x plus 1 can actually be written as e to the x plus 1 squared, like that. And that means I can this 2, I can take that out of the logarithm and that just becomes a factor, right? And this is a considerably nicer function to differentiate, I think. Alright, so let's differentiate it. So first of all, well, the 2 divided by ln, 2 divided by ln 2, that remains the same, and then I have to differentiate ln e to the x plus 1. When I'm differentiating ln, that just becomes 1 divided by the inside. And I have to multiply by the inside derivative of the inside, which is just e to the x. So the final derivative is the following: e to the x plus 1 times e to the x. Alright, that's the derivative of this function. Let's go. Okay, so it's going quite smoothly. So now we have another logarithmic thing, if you will. The natural log of x squared plus 1 divided by x squared minus 1. Alright, now actually I'm gonna quickly move to the side here. So which one was this? 13, I believe? Yes, 13. So a 13 derivative, y equals natural log of x squared plus 1 divided by x squared minus 1. Parentheses like that. Alright, again, you could just do this with the chain rule and the product and the quotient rule, but that gets a little bit messy. Now, what I like to do is to split this up like that and take advantage of the logarithm rules, if you will. Might have already shown this in a video actually, but it's important to keep those rules in mind so you don't do extra work than you need to, right? Because these are considerably easier to differentiate. Right, so let's do the first one. Ln, that becomes ln x squared plus 1 times the inside of the derivative. That's 2x plus, that's just 2x. And then I have to subtract off, well, the second function, derivative of the second function. That's going to be pretty much the same actually, except for this part. Obviously the inside just goes into the denominator here. And that's our final function. And actually, now I'd like to see what happens when I combine these fractions. So I'll multiply both sides. So I'll give them the same denominator quickly, right? 2x, right? Because I multiplied by the denominator of the other fraction to do this. I'm actually kind of curious because it might be kind of a nice thing, if you will. X cubed minus 2x, and I have to subtract off x plus 2x. Or actually, rather that becomes minus 2x. Yes, I thought so. I thought it might be a nice function. These functions aren't picked completely randomly. This becomes x. Oh yeah, this is a special kind of product. It's a plus b times a minus b, and that always becomes a squared minus b squared. So that's how I know this quickly. So then I don't have to work this entirely. I have to work this out, right? And now this becomes negative 4x, x to the 4th minus 1. Wow, that's really nice. Alright. But it did take a little bit of time. So I'll do 20. Yeah, right. The next derivative, derivative 14. Here we go. That's gonna be y. Just write it like this. X plus the square root of x squared plus 1. Alright. Okay, I'll use a little bit of different color here. This one, sadly, no logarithmic rules to take advantage of. No, I just have to do it brute force by the chain rule. So first of all, just the inside is gonna be like that, and I have to multiply by the derivative of this. So derivative of that, I can just split this up, right? Because I have x, that's just 1, and then the derivative of this, that's gonna be 1 divided by 2 times the inside, or rather just square root of the inside, like that, and then times the derivative of the inside of the square root, which is 2x. So those 2 cancel. So what I'll end up with is 1 divided by x divided by 1 plus x divided by, rather, like that, and then x. And I can actually multiply both the top and the bottom part by the square root of x squared to make it a little bit nicer. Alright, and let's see what we end up here. What we end up with, that's going to be x, rather, yeah, that's going to be the square root of x squared plus 1 plus x. And this is going to be x times the square root of x squared plus 1 plus x squared plus 1. No, it didn't end up nicer. Anyway, you can just use this one. Alright, so that's like that. I'll quickly make it a rectangle. That's the final answer of that one. It's a little bit messy. It might be able to be simplified further, but well, no need really. I don't need to. Alright, so let's do it in green. Actually, no, let's not do it in green, because I already have green. Do it in purple. Or pink, whatever you want. Oh, thank God, the next one's a little bit easier. X times sine of x. Alright, so that's going to be the 15th one. Yes. 15th, y equals x times sine of x. Ooh. Sine of x. Okay, we can just use the product rule. Relatively straightforward. The first one, they'll keep the same. Times the derivative of the second one, sine of x, that just becomes cosine of x. And then I have to add by the derivative of this times the original of that. Derivative of x is just 1. And the original of sine of x is just sine of x. So this becomes our final answer. Alright, that's a little bit easier. I have to take a little bit of a breather. Alright, the next one is tangent squared plus 1. Plus 1. That's alright. Tangent squared x plus 1. Alright, so if you remember from the trigonometric episode, the derivative of the tangent x is 1 divided by the cosine of x squared. So we can use this rule actually, because we can kind of use the chain rule, like so. Now multiply by 1 divided by, well, the derivative of the inside, which is just tangent, which will be 1 divided by cosine of x squared. Alright, and the plus 1, that just vanishes because that's, well, that's nothing, right? And actually, to make this a little bit nicer, I will notice that tangent x is sine of x divided by cosine of x. So I can rewrite this like 2 times sine of x divided by cosine of x, all divided by cosine of x squared. Don't worry, I'll get there. And then I have to multiply both sides of the fraction by cosine of x to get rid of this this fraction in the top part, because that's just ugly, and I can move the cosine down a bit, essentially. So these two cosines will cancel, and I'll get 2 sine of x, and, well, cosine squared times cosine, that's cosine cubed, like so, and that's our final derivative. Okay, let's go to 17. So the 17th function to differentiate is the natural log of cosine. Oh, right, the natural log of cosine. Y equals the natural logarithm of cosine of x. Alright, so this is just plain using the chain rule. So first of all, just doing the natural log is 1 divided by the inside. And I have to multiply by the derivative of the inside, which is negative sine. And that becomes negative sine divided by cosine. And here you can actually say that this is just negative tangent. like that. So the derivative of this function is actually the negative tangent of x. Kind of nice. Alright, so we'll do 18. Let's see, 18, that's a little bit bigger one. Sine of x squared minus 1, all divided by sine of x plus 1. Alright. Right, so let's do this in yellow. 18 is going to be sine of x squared minus 1 divided by sine of x plus 1. Alright, again you can do this brute force by the quotient rule, but you don't actually need to, because you can factor the top part into sine of x plus 1 and sine of x minus 1. And then you can see that these two parts will cancel out. Well, not completely cancel, you still have to leave it when you're doing that, but it will become 1 plus sine of x minus 1 divided by sine of x plus 1. I do lose a little bit of nuance here, because there's kind of a gap when denominator and top part both equal 0, but I'm gonna completely ignore that for now. So this one's definitely nicer to differentiate. The one that's just becomes 0, so I only need to concern myself with this fraction, and I'll use the quotient rule for that. So this becomes sine of x plus 1 squared, and after you do the denominator times the derivative of the top bit, that just becomes sine of x plus 1, that's the denominator, times the derivative of the top bit, that's, well, the negative 1 goes to 0, and sine of x, that becomes cosine of x. And for now the second part, that becomes the sine of x minus 1, that just stays the same, and then I have to do by cosine of x. So let's see if I can simplify this a little bit, because it's a bit messy. Let's see, sine of x, cosine of x, that's the first, and then I have to do add cosine. So negative sine of x, I'm just multiplying these things out, times cosine of x, plus negative and negative becomes positive, plus cosine of x. Yeah, right, it becomes a little bit nicer, some things cancel. Because sine of x times cosine of x, here I have plus, and here I do have minus, so those cancel out, and these two cosines, I can just add them together to give me 2 cosine of x, all divided by sine of x plus 1 squared, which is the derivative. Alright, let's get to 19. Alright, so I believe we have made it to the implicit differentiation, which I'm a little bit scared for. They are quite a lot harder sometimes. Alright, so it's still the goal to find the derivative of y. Alright, so this is going to be x squared minus y squared equals 2x. Here we go. X squared minus y squared, right, let's move that to the center, equal to 2x. So it's going to be the objective to find y prime. You can also say this is y prime instead of the derivative of y. Alright, fine. I'll actually move all the x's and the y's to one side. So those go that way, those go that way. And you might want to take the square root of both sides, so I'd have this. But actually you need to do both the positive and the negative square root, so I won't do that. Because then I have I have to do twice the work, right? I don't want to do twice the work, that's horrible. No, I'll actually just take the derivative on both sides right now. So the derivative of x squared, that's 2x, minus 2. And here the derivative becomes 2y times the derivative of y by the chain rule. And I have to solve for the derivative of y. That's like that, divided by 2y. Actually, I can divide out by 2, so that's x minus 1 divided by y. That's alright. And now I can actually say that y prime is equal to x minus 1 plus or minus, because now I do have to take the square root. I actually just take the square root right here. So it's plus or minus x squared minus 2x. X squared minus 2x. Right, so I actually delayed doing the square root until I had the derivative right here. So that's the first implicit differentiation. That wasn't too bad, thankfully. But I have a feeling the second one will be, or might be, maybe very doable. But it is a little bit of a big one, so that's going to be e to the 2x plus 3y equal to x squared minus ln xy cubed. Alright. So I'm not entirely sure. For me, there's no obvious way to do this one. So actually, first of all, I'll just copy it. Plus 3y equal to x squared minus, like this. So there's no real obvious way for me to do it yet. So what I'm just gonna do is just take the derivative on both sides and see where that gets me. Alright, so let's do the first one. The derivative of this, well, e to the x, that just remains the same. I have to do the multiply by the derivative of the inside. That becomes the derivative of 2x, that's just 2. Derivative of 3y, that becomes, well, the y just cancels out basically. But we do have to multiply by the inside, which is y prime. Alright. And now I have to differentiate this part. Well, x squared, that should becomes 2x. And I have the negative, the natural log, that becomes 1 divided by. Copy that, and then I have to do times the derivative of the inside. And actually do that on a separate thing, because I have to use the product rule here. Alright, because I have x times some function of x, which I don't really know, so I'll have to use the product rule. So I'll keep the first part the same, and then multiply by the derivative of y cubed. That's going to be 3y squared times the derivative of y by the chain rule again. And then add y cubed times the derivative of x, but that's just x. Alright, so this is alright then, x, rather 3y squared times x times y prime plus y cubed. Alright, so that's our final expression. So now the goal is to solve for y prime. So let's see, I have y prime right here, and I have y prime right here. Alright, so what can I do? Let's see, 2 to the... I'll actually quickly write this a little bit nicer. And actually, I'm not going to solve for y like I did here. So here I actually plugged a formula for y in, but in this example I'll just leave y as it is. Because it's just too much work. I'm not sure it's actually possible to find an equation with just y. Alright, so I'll quickly rewrite this to make it a little bit nicer. 3y squared xy prime plus y cubed. So this isn't y to the 1, this is y, the derivative of y, right? It's technically an apostrophe. Alright. Let's see what we can... I will look here first, because I feel like I can divide out a couple of things here. So that's going to be 2x. And I can... First of all, let's look at this part. Here I can divide out the x, and I can reduce the power... I can actually get 1 divided by y. So it's going to be 3 times y prime divided by y. And here I have to leave y1 over x. So, and actually I will multiply this out now like that, so that's 2 times my exponential, and then 3y prime times my exponential. Alright. So now I can group together the y prime terms and solve for y prime. So let's y prime, that's 3 times the exponential, and then I'll subtract off, or actually I'll add y prime to both sides. I'll take that over there. Then it's going to be plus 3 divided by y, and I'll subtract off this term because it has no y prime in it. So that's 2 divided by x minus 2, like that. And now I can divide out by this entire part to get me y prime. Ooh, here we go. I've made it. That was quite a long one. Alright, and divide out by 3e to the 2x plus 3y plus 3 divided by y. Alright, here we are. So that's y prime. So that's it's not very pretty, but it does work. Yeah, that's by far the longest one. So don't stress if you didn't got this one. This one's it took me a while too, right? So well, this one's quite nice. But now we have made it to the I guess you could call it the eclectic bunch. So the final 5 assignments or derivatives are kind of a combination of every rule together. So the first one is secant of the square root of x squared plus 1. So I'll do this on this side. So I have 21 is y equals secant. I do believe these are a little bit easier than the one I did just now, the implicit differentiation one. That one was, whew. Now I'm not even sure I got it correct, right? I really don't know. Alright, so the secant of this. Alright, first thing, the secant is just 1 divided by cosine. Like that. And now I have to I can rewrite it like a power, right? Because I can do this to the power of -1. And now I just have to use the chain rule like 4 times. So first of all, this power. Alright, so this power will just give me -1 out the front and reduce the power by 1. That gives me -2. So that becomes like so. -2. And now I have to multiply by the inside. That's still the cosine thing. Alright, so we'll actually copy that over because it's a little bit. Alright, so I have to find the derivative of this. And the derivative of this, that's first of all going to be negative sine of the inside. And then I have to multiply by the inside derivative of square root of x squared plus 1. That's going to be first of all 2 times the square root of the inside of the square root of what we already have, and then multiply by the derivative of the inside, which is 2x. Those 2's will cancel. Alright. So, and now I can plug this expression into here, which gives me negative sine. Alright, times x divided by, right, because I'm using the chain rule over and over and over again. Alright, now I will simplify a little bit. X times sine x squared plus 1. That's just that x and this sine. Also, negative and negative just becomes positive. And then I will copy this cosine. This cosine to be -2, that's 1 divided by cosine squared. Cosine squared is 1. And then I have to still have to do this root in the denominator, x squared plus 1. And that's the final answer. Alright. Whew. Yeah, that one was a little bit harder. That one took quite a while. It's just using the chain rule over and over and over again, and you have to have really clear how it works and what you have to multiply by what, and just working carefully with this one. Right, the next one is the third root of x cubed plus ln x. Alright, the third root of x cubed plus ln x. Again, this is probably just using the chain rule. X to the power of a third. Here I can just use the chain rule, right? This one's a little bit easier. X cubed. I can just leave the inside the same. Reduce the power by 1, that becomes -2/3. And I have to multiply by the derivative of the inside. X cubed just becomes 3x squared, and then ln x is just 1 divided by x. So now I can make this a little bit nicer. This top part, I'll just move that up here, divide out by 3 times, actually the third root of this thing, and then all squared, because that's kind of what this 2/3 power means. Alright, I won't go into more details in this one. It's not really necessary. This is the final answer. Okay, then 23. We're almost there. We're almost there. Let's take a look. 23 is going to be x squared minus 1 all to the power of 3 divided by x squared plus 1. So this looks like a big quotient rule one. So x squared minus 1 to the power of 3, x squared plus 1. So that's y. Alright, yes, I don't see any simplifications yet. No, I think we'll just have to do the quotient rule. So the quotient rule, first of all, that's x squared plus 1 all squared. And then, well, yeah, it's just the quotient rule, I think. So leave that the same, the bottom part, multiply by the top part, or rather the derivative of the top part. So let's actually work that out separately. The derivative of this, what's that gonna be? First of all, using the chain rule, I can move 3 out there, or rather using the power rule. That's squared, and then I have to multiply by the derivative of the inside. So that's the derivative of x squared minus 1, that's 2x. So this just becomes 6x times x squared minus 1 squared. Alright, so I have to put that in there. X squared minus 1 squared. Alright. And I have to subtract off the derivative of the bottom part, that's 2x, easy enough, times just a regular top bit. Alright, so I can factor out probably 2x like so. This is a 2, by the way, like that. Okay, and then I can say, yes, I'm gonna say 3x squared plus 3. This is just that 6, and then I have to divide out by 2 because I still have 2 here, and then multiplying out this x squared plus 1 term. And then I have to subtract off x squared plus 1, right? Because this minus becomes this, and this 3 is reduced to a 1 because I have factored out a squared term here. X squared plus 1. Alright, so this actually just becomes 2, and this becomes 4. Right, so I can actually factor out another 2 here. This one's just simplifying and simplifying and simplifying. It's not really too difficult. It's just, again, working carefully as always, like that. And that's the final answer, I think. So we're now at 24, just 2 more to go. And take a look, where are they? Here they are. So this is sine x to the power of cosine x, kind of nice. Alright. Here we go. Y equals sine x to the power of cosine x. Alright, as you may have guessed already, this one will be using implicit differentiation. So I'll take the natural log on both sides. Ln of y is going to be the ln of sine of x to the power of cosine of x. And that cosine of x will jump in front. Cosine of x times ln sine of x. So that's brackets really. Is ln of y. And now I can take the derivative on both sides. Again, I covered this one quite a lot in the last video on implicit differentiation. This becomes y prime divided by y. And then this one is using the power rule, of rather the product rule. So first of all, leave this the same and multiply by the derivative of this. That's first of all going to be 1 divided by the inside. And then using the chain rule, I have to multiply by cosine of x. Then add on the derivative of this, which is going to be negative sine of x, and leave the second part the same, ln of sine of x. Alright, and simplifying this becomes cosine squared, that's this cosine times that cosine, divided by sine of x. And then subtract off this minus sign, sine of x times the ln sine of x. Alright, so this is y prime divided by y still, because we haven't actually solved yet. because we still need to multiply both sides by y, which we'll do now, and y is just equal to sine of x to the power of cosine of x. So I'll just factor that out. I won't just repeat that because it's not necessary. Cosine of x squared divided by sine of x minus sine of x times ln sine of x. Like so. That's our final answer. These implicit differentiation ones, they go on forever. It's just, and then you still need to multiply by y, and then you still need to do this. Alright, so let's do the final one now. took like, how long have I been going? Like 45 minutes or something? Alright, so the last one now is gonna be this mess, whatever this is. X to the 4th times 4 to the x. Let me actually copy that on paper. Look. Okay. Minus 4 to the x divided by 7. 7th root of x. Alright, here we go. Let's scroll down. So, the final one, the 25 derivative, goes by. Here we go, let's copy that. Oh, it's a little bit messy. Minus times the 7th root. And actually I'm gonna factor out this 4 to the x term and just use the product rule. Because otherwise I have to use the product rule 2 times, which I don't like to do. It's not that fun. Actually this is the 7th root of x. Now I will quickly rewrite this one as a power of x, and then we'll start differentiating. So this becomes x to the negative 1/7. Alright, so now to differentiate, first of all, using the product rule, this remains the same, and I have to do the derivative of this. That becomes 4x cubed, and then plus 1/7 x to the, and then subtract off 1 negative 8/7. And then I have to add. First of all, I'll just keep this the same and then multiply by the derivative of 4 to the x. So like so, and then ln 4 times 4 to the x. I'll quickly simplify this. 4 to the x is 4x cubed plus 1/7 x to the negative 8/7 plus ln 4 times x to the 4th plus ln 4. This is just distributing this natural log like so. And that is the final answer. It may be able to be simplified a little bit further, but to be honest, I'm exhausted now. And right, let's wrap this up here. I hope if you followed along that you were able to follow along. And I hope you got some practice out of it. Well, I'll see you in the next part. Bye bye.